Okay, this is the second spring paper, the ones that are made by Excel, and your paper being written by Excel, probably roughly at the same time, so again, they're really important papers. For some of you that in my class have already gone through this today, but this is obviously the YouTube version, and hopefully you find it more useful if I rush through it in lesson. At least you get this time now. So first one, we had a discussion about how we knew this was a two-way table, as this is a two-way table. This has got two topics. I'll nick that offwards. Two topics where a Venn diagram will all be about one topic. Okay, so we have two topics here. So we have what they do. So let's read it. So 100 adults were asked how they keep fit. So it's about how they keep fit, obviously. Each adult goes to the gym, runs or cycles. So there's the first category. 45 is a female. Then it starts going on about males and females. So that's the other category, if they're male or female. So I'm going to put gym, runs or cycles on the top of my Venn diagram. And I put if they're male or female in any order there. And then construct very basic two-way table. Okay. Don't expect you to use the ruler there. You can if you'll make it look nice, but I'm literally trying to get the information in the right structure, so that's what I'm going to do. Okay, it says 100 adults were asked how they keep fit, and these end ones are all about the totals, so that's an important feature. So 100 adults go. 45 of these were female, so the total of 45 were female, sorry, wrong place. 45 are female, 55 are going to be male, so I know that. 30 of the 52 adults who go to the gym, so 52 adults go to the gym, 30 of these are female, meaning that's going to be 22 males there. 35 adults run. I'm just filling the gaps now, so that's actually 87, so that's going to be 13. And 9 males cycle, so 9 males cycle, so that's going to be 4 there, okay, to make that 13. And then I've got to fill in some gaps. It actually wants to know how many females run. So it wants to know this one. Okay, so I could do that right now. You've got 34 so far, so that must mean 11. Just to make sure that was 24. So there we go. So 11 females run. There we go. Just turn that down. Typical. So that's it. Nice two-way table. The way, again, to remember, if it's a Venn diagram would talk about just the gym, the running and the cycling and give you some totals for you to figure out. And it'll tell you how many run and go to the gym and so on. This is about two types of categories. Right, this question can be tackled in a couple of ways. In a previous video, we did a method where we looked for common... We did like the lowest common multiple using the ratio, but this way I'm going to do it slightly differently. I've got a different way of thinking about it, really. So a school trip, the number of teachers to students is 1 to 15. So immediately I'm going to change that information. So teachers to students, instead of being 1 to 15, I'm going to do 1 out of 16 to 15 out of 16. They're the fractions that are involved. Okay. The ratio of number of males to female students is 7 to 5. So males, females is 7 out of 12 versus 5 out of 12. Okay. What percentage of all the people on the trip are female students? So we know that 5/12 of the female students of 15 out of 16 of the whole population. Okay, and what I was explaining to you is that actually means times. It's much easier to do it this way on a calculate paper. So if I type that into a calculator, just press fraction 5 out of 12 times by 15 out of 16. I get 25 out of 64. But it doesn't ask that, it actually asks what's percentage. Okay, and a percentage, and when we deal with percentage, it ends in AGE. That is actually a fraction times by 100. That is a good hand shout out. I'm not sure if Mr. Goodhand's watching this. So we times our fraction by 100 and it'll turn it into a percentage. And another idea is if we actually looked at the decimal format, to change a decimal into percentage, you also times by 100. Okay. So it says syntax error because I'm in the paint. So I've got that. Okay, so 39.0625. Connect to the nearest whole number is 39. Okay, nice and straightforward when you know what to do. So just thinking about how we can prepare for this one. We've got a ratio within a ratio. So it's a fraction of a fraction. And that means we're going to multiply. And then the last bit was nothing to do with the actual topic itself. It was just converting your fraction into a percentage, which you just times by 100. Easy on a calculator paper. Right, next one. In the space below, use a ruler and compasses to construct the perpendicular bisector of AB. This could be a different style of question. If you see Mr. Patrick's grit work, he's done 2 points, and it might say, construct a line that shows the points that equidistance between the 2 points, or show the loci of both A and B, or something like that. But basically, we have to be able to cut this line in half at right angles. That's what perpendicular means. Without measuring it and then just marking halfway using compasses. So the main thing is put your compass point on one end and make sure it goes over halfway. I said to my class, you can do 4 massive circles, so there's nothing stopping me doing big massive circles all the way around here. But the main bit is that you just do this main arc here. That's the main bit there. Like that. And then go to the other side, keeping your compasses at the same width, so don't change them at all. If you do change them, it won't be right. And then do the same again, like that. Okay, so they're the arcs that we're looking for. A ruler. It'd be really useful if I had a ruler. Super organised. Looks like I'm going to use this basics card. I seem to remember used the basics card before. And all you got to do then is go through the 2 crosses. So this is the perpendicular bisector because it cuts through at right angles. Okay, nice and straightforward. If they're anticipating using it on these practice ones, maybe expect to see it in the summer. Okay, this question hasn't been around. This is an old-fashioned question, as in these questions used to always happen, and every student used to be able to get these ones right. But it's just that because you haven't seen it in a while, you might not recognise what to do. So you have a graph already done, and it says that is the graph y equals x squared minus 2x minus 4. That's the line there. Write down the estimates for that function, that graph, when it says equals 0, and that essentially is when it cuts through this axis here. So that line goes to the axis at 0. So it's just saying where does it cross the y-axis. Okay, so I'm going to go for 3.2 and minus 1.2. Okay, they are the estimates. 2 of them because it crosses twice. The next bit, write down the coordinates of the turning point, which is here. That's when it goes the other direction. Some people complete the square, but as the graph is already drawn, then it's already done for you. So it's going along 1 and down to minus 5 because that's halfway. So 1 minus 5. Nice and easy. Easy 3 marks. Okay, and if you have messed that one up, if you've seen the graph, you're going to use the graph, not calculate. You're not going to do any extra calculations or factorising here because it's there for you to use, especially on question 4. All right, maybe if it's near the end of the paper, you might have to do extra things. Okay, question 5. It is all about reading this question and understanding what idea you need to be using. Okay, people are seeing circles. Okay, and I've conveniently got this here. It was literally just there. I didn't plan on this one. So circles, we've got pi r squared is area, or we've got the circumference, which is pi d, or 2 pi r, depends what you use. But as the song goes, pi r squared sounds like area to me. When I need a circumference, I'll use pi d. So they're the things that I'm going to try and remember. Do not just assume it's the bottom one. Everyone keeps putting pi r squared and really annoying me. Right. The diagram shows a cycle track, and this is how it is. So you can see they'll be sprinting down here, come around the corner, go around like that. The track has 2 straight sides of length 40, so let's indicate that's 40 for ourselves. At the end of the track is a semicircle, radius 27. The diameter of each wheel of Ian's bike is 590 millimeters. He's going to ride his bike around the track once. How many revolutions, complete revolutions, will each wheel of his bike make? So basically, I'm trying to find some coin on me. Basically, he's going to ride around this track. This is his bike, obviously not to scale. It's going to go around, and we want to know. That's such a bad example. Let's say we mark that there. We want to know when it goes round this track. Let's say start at the top. How many times will it go round? A complete amount of times. So when it goes round here, how many times will the wheel complete a full circle? Okay, that's what we're going to try to do. Now, it is not talking about the inside of this shape. It's talking about going around the outside, which is a perimeter. So it's talking about the circumference, okay, the outside of this circle and just the perimeter of the whole shape. Okay, so we need the circumference of this part here. Okay, so circumference is pi d. So for this one, it's pi times 54, because if the radius is 27, the diameter is twice that, so it's going to be 54. Okay, that gives me a full circle. And because I've got 2 halves of a circle, that is a full circle anyway, so I can just leave this answer as it is. In class, I showed you can divide that by 2. You just don't have to. All right, you can just leave it like this one. So this is the alternative answer. Okay, in the end, it's asking me to round it to a whole number. So I can round this to like 1 decimal place or 2 decimal places, and I still should be fine. Okay, or like AJ, I'm not saying your name because it's on YouTube, but he said, can you leave it as 54 pi? Yes, you can. Okay, you can deal with it like that, and it will be bang on. Okay, so that is the circumference of the circular parts. That's these parts covered. So that's that bit. Okay, but we need the whole shape. So we've got 169.64 for the circular parts, and then we're going to add the 240s on to complete the whole perimeter. So I'm just adding that on. So I've got 249,646. That'll do for now. Okay, and that is the entire perimeter. Okay. Now Ian's bike is a circle. His wheel is a circle, and we've been told that this part is 590 millimeters. This actually is in meters, so at the moment the units that can't work with each other, so we'll need to convert them. So I'm going to convert this 590 millimeters into meters. So 590 is 59 centimeters, and then to turn centimeters into meters you divide by 100, so that's 0.59. We need to know how long the outside of this wheel is, so we need to know the circumference. So again, that's pi d, so it's going to be pi times 0.59. So pi times 0.59 is 1.853 blah blah blah. Okay, we need to know how many times that will fit into that. So 249,646 divided by 1.85 gives me 134.943 blah blah blah. It says how many whole revolutions are we going to do, how many complete revolutions. So we don't have any decimal parts, so it will be 134 because you don't quite make the next one. Okay, there we go. So read the question. It will not automatically be pi r squared. That again, it won't automatically be pi d. Read the question. If it's talking about the outside, it's a perimeter. It's talking about filling this with tiles and so on and filling up the area inside, then it's area. But read the question. It will tell you. Okay? Right then, next one. Oh, I said I was going to get some blocks and do this, but I'm not. I was going to get some little shapes together and try to get you to understand, but I'm not going to. So I can knock something together here. Yeah, we'll try and do this. So let's pretend this is what we've got in front of us. So this is looking at it from the side, the top diagram like that. Okay, and then the plan is where we look from it from above. So that works really well on this camera like that. It's saying if we look at it from this direction like that, what would it look like? Okay, so trying to get lined up like that. So we can see the height of the whole thing, we can see the width of the whole thing, and we can see this line on here as well. Okay, so what we're going to try and do is draw the same thing here. So we can, if we look this way, we'll see how tall the building is. So where the building is 4 tall. If we look this way again, we can see how wide it is. So we know it's 2 wide. So that's the outline. That'll give you 1. But like when we look this way, we could see the edges of this part as well. So you have to draw the edges of each platform. So platform there, platform there. That's really scruffily drawn. You will need to use a ruler. In the exam, because they print it differently, the background grid will be really faint, and therefore when you draw your lines, it'll be so much more obvious. So you won't be struggling to have to make it clear, but that's what it should look like. Okay, number 7. When we're dealing with standard form, because I can see it from a mile away, these bits here, and we're just doing calculations, it is not actually a standard form question. It is just use your calculator question. So if you start to convert these before doing the question, don't. You're not going to get any credit for that because it's a calculator question. They'll expect you to use a calculator. On a non-calculator question, go ahead. Start to convert them if you've got nothing else to do, if you can't think what else to do. But this is definitely not one of those things. You've got a calculator. So the distance from the Earth to the Sun is 1.496 times 10 to 11 metres. The speed of light is 3 times 10 metres per second. So we've got a distance and a speed. Show that correct to 3 significant figures, light will take 0.139 hours to travel from the Sun to the Earth. So, like I explained to the class, I wouldn't usually go this way, but as we're sort of closer to the exam, I'm going to use a triangle for this one, which I wouldn't normally do. So I've got don't stop. That's the way I try to think about this one. Don't stop to try and get the letters in the right place. We have a distance and we have a speed and we have to prove a time. So we're trying to prove all these times. So I'm going to get rid of the time. So it says distance divided by speed. So distance is this one. Speed is this one. It literally says it there, so it's not difficult to know why I know that. There are many sophisticated, well, there's very nice ways to use the calculator to do standard form, so I'll just show you what I mean by that. So I'm going to use the fraction button. So I can do 1.496. If I press that exponential bit, the X bit there, okay, put 11, that is the calculator notes in standard form. And that's the same thing there. Okay, so I can do it that way. Okay, I could also just type it in, and that's what I advise. If you don't know that button, you can just type it in. It takes a tiny bit longer, but there's no big deal really. So typing it how it looks will be exactly the same. There you go, no difference. Okay, so that is the total amount of time in seconds, because it only gave us units in meters and seconds. Okay, and the reason I'm dwelling on that one at the moment, you might think, oh my god, I ain't got the right answer, because that is trying to prove in terms of hours. So we're dealing with seconds right now, so we'll need to convert those into hours. So I can divide by 60 to turn it into minutes, but I actually want it in terms of hours, so that's what I'm going to do. So to turn minutes into hours, I'll divide by 60 again. Because here I'm saying how many minutes are in these seconds, so you divide by 60. And I'm saying how many hours are in these minutes, so I'm dividing. Because when I'm saying how many of these, I'm dividing. So the calculator, divide by 60, divide by 60. Okay, so I've proven that it's 0.13851 blah 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 hours. So therefore 0.139 to 3 significant figures. You could do 60 times 60 to get 3,600. Just like, say, if you're going towards more like a science lesson, that's probably the preferred method. Calculate the number of seconds within an hour and then divide that way. But this is a nice way as well to sort of make you think about what we're doing and why we're doing it. Okay, that's that one. Google is 1 times 10 to the 100. The next says, when I multiply the two values here, I will get this solution here. Is he correct? Yes or no? Now, there's no point just typing it here. We want to give a reason why it's not right, not just saying the calculator doesn't give it. And it might be a case that it doesn't go to the calculator. I'm not sure. Okay, but if I'm multiplying numbers in standard form, what we do is we reorganize it. So we'll multiply these numbers together. So let me just pretend I'm not doing that. We'll multiply the numbers together, but we'll also multiply the 10s together. So 10 to the 11 times 10 to the 9. That's what we'd do. And if I did that, what would happen is I'd get 10 to the power of 20, because you should add the powers. Okay? Dinesh reckons it's going to be 99 because he's multiplied the powers, but you actually add the powers, so he's wrong. So he's wrong, as you should add the powers of 10. Okay, nice and straightforward. It's a clever question because they're checking that you've been taught how to actually multiply numbers in standard form. So I might feature that on our starter just so we remember how to break these numbers up and deal with them easily. Okay, because it can come up on a non-calculator. Right, not bad so far. It's the same video. I'm on question 8. That's a result for me. Okay, well, I reckon I'll slow down later, don't you worry. So, find the equation of a straight line with gradient 3 that passes through point A. So gradient 3. So there's a lot of information that I can already get down before I actually need to go on the graph. So straight line is y equals mx plus c. Well, that's the gradient. And c is the y-intercept, where it cuts through the y-axis. So I already know it's y equals 3x. Right, I already know that one. But I don't know where it crosses the y-axis. So there are a couple of ways to do this one. You can write down the coordinate, or take the coordinate and substitute it in and find it from that way. Or you can be clever, as they've given us a grid, and use the gradient to plot the other coordinates. So if the gradient is 3, remember it is the rise over the run. So that's 3 over 1. They're the way. That's the way we can move on this grid. So if I go up 3, I'll go right 1. So if I go down 3, I'll go left 1. I can do that again. There I am. I've crossed the y-axis. So that's the actual line there. Now I know the y-intercept is -1. I can finish the question. The other way, the coordinate was 2, 5. So using what we've got so far, we'd add y equals 3x plus c. We didn't know that one, but we think it's 5 equals 3 times 2, add c. So 5 equals 6, add c. So I could take away 6. So -1 equals c. So I could do it that way as well. And that might happen where you haven't got a grid and you have to do it as well. Okay. Right then, next one. Natalia pays $13,995 for a car. Lauren pays $14,495 for a car. Assume that the rate of depreciation, the rate that goes down, for Natalia's car is 12% and for Lauren's car is 13%. Work out whose car will have greater value at the end of 3 years. Show you're working out. So it's going down by 12% a year. That's going down by 13% a year. This is a compound interest type question where maybe you stick money in the bank for a certain amount of years and so on. Same idea. It's a compound percentage change. So 12% a year. It starts off at 100% and goes down by 12, which leaves 88% of each year. So as a multiplier, that's 0.88. Same way, if I take away 13, they have 87% remaining of each year. So they're your multipliers. If I do 13.995 times by 0.88, that'll just decrease it once, as in 1 year. But as it's 3 years, I'll do a power of 3. And then for the other one, 4.95 times by 0.87 again to the power of 3. It's 3 years. Yeah, look at that. Look at that. So for Natalia, you got 9,537.20. As it's money, that's where I'll leave it. Then the other one, Okay. So at the end of all that, they're quite close, but the second one is Lawrence, so Lawrence is worth the most. Lawrence has greater value. Very straightforward. Assume the rate of depreciation assumed for Natalia's car was too low. How does this affect the value of her car after 3 years? So let's pretend that this was not big enough. So it wasn't going down by 30. Let's say it's going down by 20% a year. After 3 years, that means the car's going to be worth less. So it'll be worth less. Because it's getting smaller, faster. It's going down even more. Right. I was moaning at my class today about not having a ruler. Oh, so I'm not using an Align Best Fit for this, and I haven't got a ruler. So hopefully I'll do it justice. I think I might use this poster. That might be my ruler. Okay. Oh no. I found this very flowery ruler again that I found on the floor. Pretty good, look. Pretty good. So, scatter graph shows information about 10 adult snakes of the same type. So these are all same species. You've got the length and the weight of each snake. An adult snake of this type weighs 740 grams. Use the scatter graph to estimate the length of the snake. You will draw a line of best fit. You'll make sure that they're not asking you to plot extra information, which they are not. Line of best fits do not start from this corner here at all. That's a ridiculous idea. They do go roughly in the middle of the coordinates though, and in the same direction. So I don't mean like that. Roughly the same direction looks roughly like that to me. And then roughly in the middle is like that. Okay, so that's what I've got. Ours will all be slightly different. That's absolutely fine. Because the examiner allows that. In your exams, we have given you a proper ruler, so you won't be messing about like that. Okay. Now I've got line of best fit, I can use it to estimate 740. So I'm going to go across from 740. Hit line of best fit and come down. So my answer for this one is 76. 2 marks. 2 marks because I got one for the line of best fit. Stephen wants to estimate the weight of an adult snake of length 110 centimetres. He says he'll draw a line of best fit and read off the weight at 110 centimetres. Explain what is wrong with his method. Well, if you look at the data stops after 100 centimetres. There is no data, okay, for him to use. So there's no information after it, so it's unreliable, okay? So unreliable as there is, as there is no data. Or it's outside the data. That's probably a keyword, outside the data. Or it's an extrapolation. There's another one. Okay, but we don't do stats anymore, so we don't need to go there. Right, in standard form, write this number. It does not say round it. It means write everything down. So 4.7805 are the numbers that are involved. The rest can go. Position is 1, 2, 3, 4, 5, 6, 7. So it's times 10 to the 7. Next one. It's only worth 1 mark, so they expect you to remember the difference of 2 squares. X is squared. This is squared. This is a takeaway known as difference. So this is the difference of 2 squares. It's very straightforward if you can recognise it. You have the square roots of both terms in your brackets with a plus and a minus. Done. Okay, box plots. Key thing to know about box plots, you've got the median in the middle, you've got your lower quartiles, you've got your max and your minimum values. That's what's going on here. The table of information is there. This is the graph he's trying to draw. What's wrong? First thing that's obvious is that something may be plotted incorrectly. So that's correct, that's correct, that's 30, that's 32, that's wrong. So the median is, just make sure I'm there, isn't plotted correctly. Okay, so there's one. Upper quartile's fine, and it's got the range is 55. Well, the range is 55. They've plotted the range at 55. That should be the maximum value. The maximum value is the biggest number, take away the smallest. Okay, so something we don't actually know, the biggest number, take away 12 equals 55. So if I actually added 12 there, the actual maximum value is 67, not 55. So they plotted the range. Plotted range, not max value. Okay, that's what actually happened. Okay, it should have been a 67, so they wouldn't have actually drawn it on here at all anyway. Okay. Simultaneous equation. I'm hoping that you smash these ones. I'm really relying on you doing well with these ones. It's got a decimal, so what? I've got a calculator. It's got a negative, so what? Okay, we've just got to be careful what we're doing. Okay, right then. So, simultaneous equation. We know we're going to try and get rid of an x or a y. We do that when the number is the same. No number is the same. So that's 4 and 7. That's 6 and 5. We'll do something about that. So I'm going to multiply the top equation by 5 and the bottom equation by 6. Okay, I always try and get rid of these ones. Okay, that's just the way I do it. So when I do that, that gives me 20x. So I'll do 4x times 5, then 6y times 5, and then 5 times 5. Then 6 times 7 is 42x, 5 times 6 is 30y, just what I wanted, and then minus 10.5 is minus 63. Okay, so use your calculator, that's what it's there for. I'm then going to write down stop. So we'll stop. And if the signs are the same, we'll take away. If they're opposites, we will add. So this is what we're getting rid of. The signs are clearly the same, so we are going to take the two simultaneous equations away from each other. Okay, so doesn't matter which way round you do it, but sometimes you can save yourself a little bit of hassle. If I did take the bottom from the top, I'd have minus 22x equals 88. So I have to be careful with taking away a negative. Or I'll do the top equation from the bottom equation. So 42x take away 20x is 22x. And then do 63 minus 63 take away 25, which is minus 88. Either way, it doesn't matter. You're going to end up with a negative anyway. I'm then going to divide by 22. So x equals minus 4. If you're not sure, use your calculator. There's nothing wrong with using the calculator in a calculate paper. Okay. Alright, so that's what you do. That's the first step. The second step is to take that answer and find the y. So I'm going to tell the examiner which equation I've chosen to substitute into, and then change the x for the number I think it is, like that. And then I'm going to solve the equation to find y. So I'm going to add 16. So 6y equals 21. I'm going to divide by 6. So y equals 21 over 6. So it's 3.5. So x equals minus 4, y equals 3.5. Easy peasy. Okay? I'm relying on you getting these ones right. Okay? Right, this isn't, we didn't discuss this one in lesson at all. Okay, so hopefully this is where, if you are proactive and you see this video released before I see you next, and you've gone through it, you can start the grit stuff that Mr. Patrick's done whilst the rest get on with watching what I'm doing, okay? So if you are watching this now, it's really going to pay off because you're going to be able to practice the things you've got wrong again and again. Right, prove algebraically the difference, so the takeaway, the subtraction of two things, between the squares, I'm going to square something, of any two consecutive integers is always odd. So we're going to square something, we're going to square consecutive integers. Alright, so let's just see what they look like. So no odd or even starting values, it's just consecutive numbers. So that is those. They're going to be squared. And they're going to be taken away. Now, when we take away, we do actually do the big, take away the small when we find a difference. Doesn't matter if you didn't do that. And in the end, it will be an odd value. That's what we'll find. So that's what we'll do. So let's expand this. That gives me n squared plus 2n plus 1. Okay, I have skipped the expansion. And when you square n, it's just n squared. The n squared here will cancel out because you've got a positive and negative, and you're left with 2n plus 1. 2n plus 1 is an odd identity. That is odd. Okay, this part is even. 1 is obviously odd, but when you add the odd to it, it always makes it odd. Okay, so this is always odd. Okay, proof, comment done. The next one. Question 16. Question 16. God, have I ever got this far in an exam without doing the next video? I'm just looking at all the questions I've got. I wonder how far I can go without having to like stop it. We'll see. Right then, so question 16. Describe fully the single transformation that maps M to N. So going to the big one. Okay. It's changed size, so I'm just going to write enlargement first because I know it's an enlargement. Do not combine your transformation, sorry. So don't start whipping in a rotation because it looks like it's upside down. Enlargements can be upside down. So with enlargement, I need a scale factor and I need the coordinate, the center of enlargement. That's what I need. Because it's upside down, the scale factor is a minus because it's upside down. Okay, so it's minus whatever. Now, if I look at this, this is 2. And this is now 4. It's upside down, but that's gone from 2 to 4. So it's actually 2 times bigger. So it's been multiplied by a negative 2. So it's been enlarged by a negative 2. Okay. Now, to find the center of enlargement, you just connect up the corners. Like this. Like that. I could do the other one if I want to. There we go. Got it there. And so the center of enlargement is 4, 6. So that's the center of enlargement. So I'm actually write scale factor. Stop being lazy, really. Scale factor and center of enlargement. So single transformation, choose one. Fully means have all the information like that. And there you go. Right. Question 17, one video, come on. Right, the diagram shows Helen's fish tank. The fish tank is in the shape of a cuboid. All dimensions are correct to the nearest centimetre. That's the clue here. A lot of the maths teachers, a lot of the kids as well, naff this one up. When it says nearest centimetre, it's telling you that it's been rounded. So it means that it's expected to use some bounds work. That's what it's expecting. Okay. Helen is going to use a bucket to fill the fish tank completely with water. There are 14 litres. Correct the nearest litre in a full bucket of water. Will 25 buckets of water definitely fill fill a tank? Justify your answer. So there are 25 full buckets. So 25 full buckets. Let's see that. 25 times 14. Oh, I was doing a mistake already there. That's also been rounded to the nearest litre. So I've got to start working out some bounds before I can do this question correctly. Okay, so let's just start working out some bounds. So these have been rounded to the nearest centimetre. So let's just write down the upper and lower bounds for these units. Okay, so I've got 120, got 40, I've got 70. So bounds, remember, go below 1, above 1, go bang in the middle. So 119.5, 120.5. That is the lower bound and the upper bound. 40, so go 39, 41 to have 39.5, 40.5. Lower bound, upper bound. One below, one above. 69.5, 70.5. I wish I'd put these numbers further apart from each other because I had to squash these in. So you get your lower bound and your upper bound. Okay, we may need to use different combinations of those. We'll look in a second. And there are 14 litres correct to nearest litre. So this is the dimensions. This is the cuboid. This is the bucket. There was 14 litres to nearest litre. So going down by a litre, up by a litre. There we go. So lower bound and upper bound. We've got all the bounds sorted. Okay. So, will 25 buckets of water definitely fill the fish tank? Justify your answer. Okay, so we have to think worst case scenario. Now, the worst case scenario is that you'll run out of water, which means you had loads of water to begin with, okay, from here, and your bucket was really small. So the worst case scenario is that you're going to use the lower bound for the bucket, so the smallest one, so we're going to use that. And we're going to have the maximum volume capacity from the cuboid. So we're going to use the upper bounds to calculate the volume of the cuboid. That'll give us the maximum capacity in litres, okay? And then we can divide that by the lower bound of the bucket, the smallest possible bucket, to find the amount of buckets it will take, okay? So I'm not actually going to do it that way. I can just do it this way. So I'm going to do 120.5 times by 40.5 times by 70.5 to find the maximum volume. Okay, so the maximum volume is that. Okay, there are 1,000 centimetres cubed in a litre. So that's centimetres cubed. To turn it into litres, I'm going to divide by 1,000. So, did it twice. Gives me 58.5326, blah, 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 blah. Okay. And then, what I need to do is see how many of these litres will fit into 58 point something. So, 58.5326 divided by 13.5. Okay, so divided by 13.5 means it will only take 4.33 buckets. So will it definitely fill it? Will 25 do it? Yes. And I've done all the proof there. Okay.